Morning, everybody. So this is a continuity of the previous session where we use ACF to identify the possible, say, the pure MA and pure AR models. So we can just have a look at the series or the ACF we have constructed. So we have AR2, which consists of so AR model basically we use the PACF to identify the order of AR. So since there are two significant spikes, so this most probably might be the AR model. But of course, it has to be associated with the decay gradually ACF legs. Okay, guys. So for AR1 and MA1, we have only one spike. Right? So since this one basically the decay will be not significant, but PACF is identified the AR1. Whereas for MA2, so we're going to look at ACF here, where there's two significant spikes. And MA1 with one significant spike in the ACF. Okay, so this is how one way to identify the possible AR and M models. So if you check back to this diagram here, you can see that the question is why if you check the ACF for MA model especially, there's only one spike for MA1. This is basically the MA1 model. We have only one spike, so the MA2. So for the ACF basically. So for AR model, we're talking about PACF. So this is AR1. This is AR2 model. So now we want to analytically we try to show this one, right? Why this is happening. So first you look at the MA1 models. So your MA1 model, let's say the XT representing the, so this can be return series, price, return, volatility, all this XT. Okay? So the MA model actually have a leg one of the white noise ZT and the current ZT, which is going to influence the XT. Okay, so first of all, we just check in order to find out the covariance or the correlation of autocorrelation. Okay, for MA1, so normally we start with the mean. Okay, so where the mean value, which is the E of the XT, equate to the E of ZT as the data expected value operate on the ZT. So from this equation, we found the E of ZT basically is equal to 0. So here, this basically all gives us a 0 result at the end. Okay, so for the covariance, we have covariance XT. So for this case, most probably you can use the T minus K or XT and XT minus tau. Okay, tau is the lex value. Tau is the lex value. So you can have a covariance of. So when you extend this XT, you have a ZT plus data ZT minus 1. XT plus tau, you're going to have ZT plus tau plus data ZT minus 1 plus tau. Okay, Okay, then we're going to find out the pairs of the covariance of xt involved. So we know that the covariance of xy, so this is in general, we have the E of xy minus the individual xn, individual expected value of y. So here we just use the E of zt plus theta zt minus 1 multiplying zt plus tau theta zt minus 1 plus tau. Okay. So this is exy basically, minus the individual E of zt plus theta zt minus 1 multiplying the E of zt plus tau plus theta zt minus 1 plus tau. So this is the overall values. So then we can multiply everything and have a look at the results. For the first part, so for the second part here, basically this should be 0, so this should be 0 as well. So we end up to have the E of so-called xy here. Okay? So if you have the combination involved, you have E of zt and zt plus tau. Then you have theta and zt plus tau. Zt and you have theta here, zt minus 1 plus tau. Next value, zt minus 1, which is this one, theta zt minus 1. So lastly is the terms with theta squared. So this will be the four terms that will contribute to your covariance value. Covariance value. So here, if you substitute a different tau value, you should get a different covariance value, isn't it? So you can actually form your covariance of xt, sorry, it should be xt plus tau. Okay, so for the first case, when the tau is 0, then you have E of zt squared. If tau is 0, zt and zt minus, so basically the covariance, so obviously because the zt is a white noise, therefore the covariance between any z, let's say s and sr, will be equivalent to 0 if the r and s are not the same, because they are independent. So now if tau is 0, you have a E of, so this one you have a E of zt squared, because the tau is 0. So when you substitute tau is 0, so let's say this is tau. So if tau is 0, this is zt minus 1. So zt and zt minus 1 will be 0. Okay? Then the last term, zt minus 1, zt, so this will be 0 as well. So you have E of zt squared. So the last term, zt minus 1, zt minus 1. So you have a plus theta squared E of zt minus 1 squared. So we know that the zt is following the variance. Okay, so this is the variance of zt is equivalent to the sigma squared. Okay, so this will be the sigma squared actually, because the E of zt is 0. So this will give us the value of sigma squared plus theta squared sigma So in short, this will be 1 plus theta squared. Okay, 1 plus theta squared. So when the tau is, because the covariance function actually is an even function, okay? So the plus minus 1 should provide the same result. So if tau is plus 1, so this will be, let's say we use plus 1, tau is plus 1. So this will be 0. Tau is plus 1, then this will be the non-zero term. So you have a delta Ez squared. So you have a E of, what is this value? Theta E of ZT squared. Theta E of ZT squared. So the rest of the terms, t plus, if tau is 1, then it's t minus 1, t plus 1. So this will be 0. T minus 1, t. So this will be 0 as well. So this is the only values, which is theta sigma squared. So how about if the tau, the legs actually is more than 1. Let's say 2, 3, 4, 5, 6. So if you look at, substitute any value with tau is 2, t and t plus 2 is 0. T and t plus 1 is 0. T minus 1 and t plus 2 is 0. T minus 1 and t plus 1 is 0. So all will be 0. If we substitute 3, 4, 5, 6, all will be 0. So you have a covariance function in this particular way. So the autocorrelation function afterwards, okay? Autocorrelation function. So this is the ACF you have observed, which is rho, or actually the Rx. So let's say we use the just a symbol here, okay, for different version of tau. So this actually referring to the divided by the variance itself, isn't it? Still remember this one? We have a tau gamma x of tau over the gamma 0, which is a variance. The variance as you see is this particular value, isn't it? So this divided by this 0 and 0, then is actually gamma 0 over gamma 0 for x. So the gamma x0 is actually these terms. Okay, so this term over this term, it will be 1 itself. Okay, so you have a tau equal to 0. So tau is plus minus 1. Basically, is this value over the variance. Okay, this over this. So you have a theta sigma square over what is the value? 1 minus 1 plus theta square sigma square. So then you can rewrite this as theta 1 plus theta square. So the rest of it, since this is all 0, so you end up to get the 0 terms. Right? So this is tau, which is larger than. Okay, in this way you have successfully plot the ACF. So this value actually depends on, for example, if you like to plot the graph for ACF and A1. So you can see after leg 1, leg 2, 3, 4, 5, 6, and so on, this is all 0. So only the first MA1, you have only one non-zero terms. Okay? So therefore, you're expecting to see something like leg 1, 2, 3, 4, 5. Okay, theoretically, it should be all 0. Okay, but in the simulation, most probably you will get a non-zero values due to the random terms. And the leg 1, basically, if your data, let's say, is 0.7, then you're going to have 0.7 over 1 plus 0.49, isn't it? So you have a quite significant spike in your ACF MA1. Okay, so this is what we obtain. So this actually shows that why MA1 actually have only one spike, one significant spike in the ACF plots. Everybody get the idea? Okay, so the question is why MA1 has one spike in ACF only? Okay, so analytically, if you have a MA1 models with the white noise lag 1 and the current terms influence the XT, which can be price series, return, or volatility series. So we found that the covariance function or the autocorrelation function is non-zero terms at lag 1. Okay? After that, all will be 0 theoretically. Okay? So this is the simulated result. Therefore, you still see some ACF values which is non-zero, but actually it's statistically not significant. Okay, 95% confidence level. Okay, guys, so this is the first MA1 model. So next session we are going to see the AR1 model. So why AR1 model? We are expecting to see in the ACF tail off gradually for the ACF. Okay, till then, see you guys after.